Now in this sequence of videos I want to explore this idea of proof, and it's an idea which is really central to mathematics, in the sense that everything you've ever done without fail has been proved. Okay, and basically with mathematics, the thing which sets mathematics apart to other sciences is that if you prove it's true, you prove it's true for all cases without exception. Okay, nobody can come along and dispute that, unless of course the proof is wrong. But basically, if the proof is right, if it works, you show it's true, unequivocally, without exception. So you should already have this idea that proof is very much just based on evidence. Okay, so proof and evidence very much go hand in hand. And the proof which you study in your course is this proof called induction. There are others, but in my opinion, this is the neatest one. And in actual fact, there was a really famous piece of mathematics called Fermat's last theorem. Had mathematicians stumped for 400 years. They couldn't prove it. It looks really simple, but it was so difficult to prove. It took 400 years to prove it. And in the end, a mathematician called Andrew Wiles in 1992 used induction as part of his proof, as part of a bigger proof, I should say, to show that this deceptively simple thing was in fact true. So it's a really simple piece of simple idea, and sometimes I think the simplest ideas are the best, and this is definitely the case here. So if you just sort of think about the definition of induction, it means the process to bring about or give rise to something. So already in your mind you should be thinking, okay, so I'm going to set something off, I'm going to cause a chain reaction. And the best way to visualise induction, in my opinion, is through the use of dominoes. Because induction, one of the characteristics of induction is that you can only deal with integer cases, so n equals 1, n equals 2, n equals 3. Okay, so if you put all those integers in ascending order and assign a domino to each one of those cases, okay, so this is n equals 1, 2, 3, 4, etc., etc., then basically you want to set up, the whole idea is that you want to set up your proof such that if you can show that the first one is true, then that automatically shows that all the following your dominoes are true as well. So you're simply you knock over the first domino, you show that's true, you knock over the first domino, then you automatically show that all the following dominoes must be true as well. Okay. So in other words, you have to show that these subsequent dominoes rely on the previous domino. Okay, so the first domino. So you're literally setting off a chain reaction. Okay, and it's done in 4 steps. Okay, the first step is what's known as the base case. So you have to actually show that the first domino is in fact true. So you have to show it's true for n equals 1. Sometimes you do have to show it for n equals 2 and 3. That's in the case of recurrence relations. We're going to look at that. Don't worry about it too much in the moment. All you have to do is basically show it's true for the first domino. And that's simply just a case of putting in your n equals 1 in and showing that it works. Sometimes it's as simple as showing that, well, often it's as simple as showing that the left-hand side equals the right-hand side. Everybody can pretty much do that. The next step is basically assume that a general case is true. Okay, so you basically can go and select any domino that you like. Okay, it could be the first domino, it could be the 7th domino, it could be the 257th domino, it could be the 4376th domino, whatever domino you like. Okay, that domino will be represented by k. So it's a general domino. You can go and select any domino you like, and that domino will be k, or represented by k. And you assume that that is true. Okay, and then this is the crucial step. You basically then have to show that the next domino after k, the k plus 1 domino, is true if, and only if, that k domino is true. So the previous domino is true. So what you're basically doing is showing that, let me say that again, what you're basically doing is you're showing that the next domino is true if the previous domino is true. So it very much depends on the previous domino being true in order for this one to be true. Its truth depends on the previous domino being true. Okay? Or you can look at it another way. If this domino is true, then that automatically implies that the next domino is true. Okay? Then the final step is your conclusion step, and that's very much just putting it all together. So, things which you have to say. N equals the k plus 1 domino is true. The k plus 1th case is true if the previous case is true. Okay? And because you've shown the first case is true, then look, that in this case, your general case, your k is 1. Okay, so your k, your general case represents n equals 1. Okay, so, and you've set up here that if this case is true, then it automatically implies that the next case is true as well. Okay, so in other words, in this case, the second case is true. So you now know that 1 is true. Because 1 is true, then 2 must be true as well, by this. And because 2 is true, then 3 must also be true now. So you now know that 1, 2 and 3 is true. And now because you know 3 is true, then 4 must also be true as well. Because 4 is the next domino, 4 is the next case. So that must also be true as well. And because 4 is true, now 5 must also be true, and so on and so on and so on. So basically what you're doing is you're setting off that chain reaction. You're literally knocking over those dominoes. You set off the first domino, you've shown that's true, then that automatically shows that all the subsequent dominoes are true as well. Okay? So you have to say then, since n equals 1 is true, then n is, which is greater than or equal to 1, so all the n's which are greater than or equal to 1 is also true, where n is this thing, which is the positive integers. Now, if you want to visualise that in some nice, neat, little sort of colourful poster, I suppose, you've got this. So the first step is the base case. Second step is the general case, n equals k. Third step is showing that the next case depends on the previous case. Okay, and the fourth step, tick is true, is your conclusion. So n equals k plus 1 is true if n equals k is true. And because n equals 1 is true, then that is automatically implies that all n are true. Okay, and there are 4 types of induction. I'm going to do a video on each. The first type is your series. So basically you have some summation, and that's going to be equal to something, and you have to show that it's equal to something by induction. And the second type is your divisibility and multiplicity. So you basically have some function, and you have to show that that is divisible by some number. Your third type is your occurrence relation, and that is you're given some information. So you're basically usually given your first sort of few terms. Usually the first term, might be the second term, third term as well. And you basically get given the n plus 1th term. That n plus 1th term will depend on the previous term. Okay, then you have to prove or show that the nth term is given by some formula using that information. And your fourth type, people always seem to struggle with matrices. I don't know why, because in actual fact I think they're the easiest type. And it's basically you get given a matrix which is raised to some power of m, and you have to show that that's equal to another matrix, and that other matrix will have elements which depend or have m on them. Okay, so yeah, all of those proofs will be using proof by induction, and we're going to do a video on each of those.